John here again with another video, and this is part 5 of the CIDOS development video series. And in this episode we're going to be, I'm going to be explaining the scratch, the header and the device commands. Now, as you probably saw last week, we had a few issues with a 255 in the character get and character got command. Right, I looked back at my notes, and the reason why I was doing that is because potentially you could have a space in the file name, and I didn't want the space to be stripped out in the file name, and that's why I put 255s in. So what I've done is I have created a macro to do this thing. So I load whatever the number is and I put it into the byte that is for character hex 20, which is the space. And the reason why I put 255 in is because there's no ASCII character per se that we use, which is 255, so we should never, very rarely hit it. So if we go back to the rename command, as you can see I've put it back in. So what I've done is I've put it and changed it to 255, then get the file name. So if the file name has a space in it, it will still read it as a space. And then when it's finished with the file name, I put it back to space, so it strips out the spaces outside of the file name quotes. So if it says space 2 space, then it'll strip out the spaces and only give me the tokenized word 2. And then I put it back to 255 to get the next file name, and then I put it back to space after that. And that is why I and I had to go back to my notes from a year or so ago to remember what I've done, because it was such a long time ago. Anyway, so that has now been resolved. So it stops testing for a space, it stops stripping out spaces before I check for a file name, and then puts it back to how it was before. So here we go. So in CIDOS now, and I've added scratch, header and device. So if I go into scratch, so this is scratch basically, and I need to put that in there. So we're putting the letter S into the DOS buffer, and then the colon into the DOS buffer plus 1, and then we're loading the index to be 2. So we turn off stripping off spaces, and then we go and get the file name and put it into the DOS buffer, and then we put this stripping off spaces back in, and then we jump to DOS, and it's as simple as that. So we can try this out. So if I go back to CIDOS and rem that command out, there we go, scratch, do a build, there we go. So we're going to load our disk image in, and as you can see I've got TDSOS, TDSOS1 and TDSOS2. So we will scratch TDSOS2, turn on drive emulation. So SOS 32768 quotes TDSOS2 unquotes, and that should be it. So press enter, we should see the command. There we go, scratch TDSOS2. Are we sure? Yes we are. So it's now performing the scratch, and it says 1 file scratched. So if I load it in, there you go, it's gone. So that's scratch. Now the next one is header. So let's close that one down. There you go, header. Now in header we are basically we're looking for the file name, and we're also looking for the identifier of the disk. If you remember, the identifier uniquely identifies the disk, and so it should, each disk should have its own ID. So therefore, when you put the disk in, it doesn't need to it automatically rereads the BAM. So what we're doing here is we're loading the new command into the command buffer, and then colon. We turn off stripping off spaces. We get, and now we can use the same file, the same routine, get file name from command line, because it's exactly the same. So we get the file name, and then we turn space stripping back on. We then check for a comma, and if we don't get a comma, it will use the default ID. Sometimes I think that's 2A, I think it is, something like that. But if it does detect a comma, then it comes and finds, so we strip out spaces again, and we do get the next character, we load the comma into the buffer, and we then store the next two characters. So the next two characters should be either 01, 12.6, not 12.6, T6, or stuff like that, and that would be your unique identifier when we are formatting the disk. Alright, so the problem with this though is I need to make a disk. So can I make a disk? Yeah, create disk image. Here we go. So I'm going to create a test image .d64. Gonna put it in, well, might as well put it in there, test. That's it. And test header. Okay, that's it. That's the image created. Now that's already an image. So when we try this, we're going to override that image and format it. So we'll save that. Go back to here and we'll unrem out the header, and we should be able to format that disk. So here we go. So we're going to load, we'll attach the disk in. Now this is not in the right place, so there's the test disk, and we'll turn on true emulation. There we go. So if I load the directory in, we shouldn't have anything in there. There we go. So SYS 32768. So we're going to do the format header, comma, and we'll give it TA as the identifier. So we're going to say no to that because it's missed off the T. So we'll just, am I stripping off an extra character that I shouldn't be? Header. So is it comma? Yeah, I'm stripping off an extra character here. Don't need to do that. So we'll run that out. Do it again. Oh, specific address. Here we go. Load our test image in. Test. Set on true emulation. SYS 32768, and it's format test, comma, format test. There we go. Press enter. And there's the DOS command, so new format test F3, so we'll say yes, and off it goes. So this is now formatting the disk because we put true emulation on. So at track 6, track 7, 8, 9, 10, 11, 12, 13, 14. Now this, so we're halfway. So it's just written the BAM. So 25. At 31, only a couple more tracks to go. There we go, it's formatted it. So load it in. There, format test with the unique identifier FT. So that's the header, and I'm not calling it format because if you do F Shift O, that's 4. And so we'll leave it as header, so that'd be H Shift E, and I don't think there's a command like that. And then the last one is the device, where we're swapping device numbers. So what we're going to do is we're not going to get the next character, we're going to get the current character, and we're going to test to see if there's a character there. Yeah, because when you want to change device, it will be, you type in the word device and then the device number. So we're going to check to see if there's a number there. Alright, if there is, if there's no number, because we get nothing back, then we're going to print what the current device is. So we're going to come here and then print the current device. So you can type device and it would say this is device 8, or you could type device 9 and that would change it to device 9. So if we found a character, then we're going to get the number from the command line, and we're going to check to see if there's no device number, and if there is, it just prints it. So even though we found a character, it may not be a number, so we just say if it's not a number, we're going to just, if it is number, we're going to store it in a location, and then we're going to close the current disk channel, yeah, and then we're going to test, is it for the range of the device. So if we're going to test X with 8, and if it's less than 8, we're going to go to an illegal device number error. And then if it's greater than 8, then we test it with 13. And if it's greater than or equal to 13, then we're still going to jump to the illegal device error. And if it's between that range, then we store it in the device number, and then we reopen the channel, and then we confirm that the device has changed by printing the device number now. Now, the illegal device number is no such thing in BASIC, so we've had to create our own device, our own error message. So I'm loading X with our invalid device number error, and then I'm jumping to error handling. So if we go into error handling, you'll see on the next number is error 30, yeah, and error 30 is illegal device number. So when we jump to this, it should print out an illegal device number, and we'll try that out. Okay, so let's try it, shall we? Let's see if we can change the device number on this thing. So I'm going to build it. Oh no, got to include it first so we can run it. Here we go. So the first thing is, if we just do SYS 32768, we should get the message saying what device number we're on. Yeah, the current device number is 8 and everything is okay. So if we do SYS 32768 space 9, ooh, Legal quantity. Ooh, hang on. Right, I'm going to have a look at that. It looks like the basic interpreter's getting in the way. Because I think when we ask it, it's trying to do that. And because I put a comma there, it's just gone into... Yeah. We'll have to see. I think the basic interpreter's getting in the way of that. So I'll have a look at that. Because I think what it's trying to do is trying to get this number, which it is correct. It's an illegal quantity error. 327689 is too big a number for an integer, for a 16-bit integer. So I will have a look at that and do a little bit of research on that routine, because that routine should have ignored it and carried on from here. Done 8 or 9. So. Now it's definitely reading a number. Too big a number, I think. Right, I'll have a look at that and I'll come back at you, and with the next... Well, I mean, I'll if I figure it out, I'll explain it in the next video. Alright? So, the next video will have... I think I'm doing the catalogue command, where we go off and actually get the catalogue. I think that's in the next video. I'm going to be writing that, putting some, and make sure I've got proper error trapping in, because you know, don't want it crashing. Alright then, with that I'll talk to you later. Take care, bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys I wouldn't be able to do what I'm doing right now. Thank you very much.